Now that you've secured your network infrastructure, the next step is to decide which devices and which people are allowed to communicate on your network. This is known as network access control. Clearly, if you restrict network access to authorized users, you greatly reduce the opportunities for an outsider to attack your operation. iOS on its own offers a range of configuration options to meet your requirements. But network access control is becoming ever more sophisticated. As your demands become more complex, you may find that using iOS devices together with external authentication software will provide you with the most granular solution. Ease of use is one of the main reasons that Ethernet became the dominant LAN protocol. If you want to get access to an Ethernet network, just plug your PC into an unused switch port and you are good to go. In the past, this was perfect. Today, the connection of unauthorized devices is one of the main causes of security breaches. It's also one of the easiest to prevent. If your switch is in an accessible location, disable the unused ports. This will deny network access to any devices which are connected to these ports. Imagine this scenario. A potential attacker tries to connect to your network by plugging his PC into unused ports on a switch. He is never able to establish communication because the ports are disabled. So what will he try next? Probably he will unplug the cable from a working port and connect his own PC. You need to ensure that he is still unsuccessful. Port security defines which MAC addresses or VLANs can use a port. Packets received with an unknown source address are discarded. So in the scenario we described, if you've deployed port security, the attacker would still not get access to the network. Port security can also be used to restrict port access to a defined number of MAC addresses. In this case, the number of addresses is relevant, not the specific addresses. So why would you want to do it? A number of network attacks are based upon the ability to fill up the learned address table, also known as the forwarding database. This is done by transmitting a large number of data packets with different source addresses into the switch. When the learned address table is full, packets subsequently received are flooded to all other ports on a switch. This facilitates the interception of communication which is running through the switch. MAC flooding prevention can also be used to prevent DHCP starvation attacks, which we will cover later. Earlier, we looked at using radius authentication to allow a user to connect to a switch. A very similar technique is widely used to allow a device, such as a PC, to access a network. When a PC attempts to connect to a network, the switch uses a protocol called 802.1x to put the client on hold. The switch checks with an authentication server, such as a radius server, whether the PC is allowed to connect to the network. The client is then allowed or denied network access. The client could also be assigned to a specific VLAN, for example a guest VLAN. Network access control using 802.1x is commonly used in IT networks today, and its deployment in OT networks is increasing. 802.1x authentication works well in modern networks where all devices support the protocol. But in OT networks, many industrial devices do not support 802.1x. So, does this mean that you cannot use authentication for network access at all? Actually, no. iOS supports a feature called MAC authentication bypass. This allows authentication of older devices to be based on the client MAC address. It's not as secure as traditional authentication because the client MAC address can be spoofed. But it's a big improvement compared with no authentication. Even better, iOS enables you to mix 802.1x and MAC authentication bypass on the same switch, giving you the greatest flexibility.